Oh, okay. Hey guys, welcome back. It's morning here about 9:20 Indiana time. Greetings from Indianapolis. Well, actually, I live in Fishers. It's about 20 miles northeast from Indianapolis. So those who are tuning in from Indianapolis, howdy Hoosiers. Okay, let's. Today I'm trying to discuss about Kaggle. I love Kaggle. If you haven't heard about Kaggle, you should go. Basically, it's a playground for data scientists, basically, or machine learners or deep learning. But in general, it's a machine playground for data scientists, and everything is kind of free. It's being bought by Google several years ago, so now it's I think managed under Google, which is good. Uh, Google basically give give like good things to the public for free, so we can like play around with it. So if you're an inspiring data scientist, and data scientist is going to be, it's already hot right now. It's going to be probably the next, I would proceed 10, 20 years. It's going to be like in a high demand. If you want to contribute to the society, make bringing a better world, I think data science is a good bet to be, or a good career, or a good, so to speak, calling. Yeah, if you want to say it, calling to be in, because then you can help a lot of people how to make decision effectively. Because data science is basically about you got all of this a bunch of data, big data coming in, and you are given the tools to analyze what how is the data making sense, and how do you want to proceed as a company or as a team, given the data that you have, tons of data, what should be the most valuable decision, yeah, in terms of economic value, in terms of providing like helping people in the non-profit world, or helping people in the even in the profit world. And that's very valuable, because you want to go in the direction where it's leads to something valuable, something that you can be proud of, right? If you are, no matter how smart you are, if you're going into the wrong direction, then all your energy, resources, time, money, and all that, it's going to be all wasted. So making decision where to go, that's not an easy task. Sometimes it's easy, sometimes it's not. With a lot of data coming around, it's going to be much, much more difficult to decipher where to go, right? And fine tuning this balance of where to go precisely, it's kind of the job of data scientists, basically answering the question, where can we go in the future, or where can we go now, so we can uh, get to a better world, so to speak. So, so today I'm trying to do this courses from Kaggle. It's called basically Introduction to Machine Learning. So machine learning is basically it's a subset of data science. It's called machine learning because in the traditional world of programming, uh, the the programmer will instruct the machine what to do, right? Step one until step 10. But in the machine learning world, it's basically the opposite. Instead of the programmer instruct the machine what to do, now the job of the the person, so to speak, people like me who call themselves learning engineer or data science, will just give like a act as a teacher, give them a bunch of data, and the machine will learn on its own. Machine will learn on its own, which means it's gonna basically create a algorithm or instructions, a bunch of instructions, sometimes a bit black boxy they call it, because we do not know how exactly the machine make that decisions. But it's gonna be, don't worry about it. It's gonna this thing is a very dynamic field, and like Google and Apple and even I think Facebook recently just announced that they can actually go inside this black box algorithm that the machine generates kind of like a big function, big algorithm, right? With like millions of parameters, then you can actually human can actually take a look at it and then can understand better what makes the machine makes that kind of decision, right? So that's the the general idea of a machine learning. So now we are going to go to level one here. Let's see how far today we're gonna go. We'll just try to um, and probably my juice gonna be running out after 1 hour. So we'll see how far. Okay. But I'm just gonna take it slow one at a time. Hopefully you can learn with me. All right. We can. This is helpful. So introduction. So I'm just gonna make this bigger. Okay. So we'll start an overview of how machine learning models work and how they are used. This may feel basic if you've done statistical modeling and machine learning before. We'll progress to building powerful model. Okay. So your cousin made millions of dollars. Okay. Uh, speculating on real estate. He offered to become business partner with you because of your interest in data science. Hmm. So this is kind of like good scenario where people kind of like understand making money through buying and selling house, right? Real estate. So your cousin is gonna give you the money, and you'll supply the model means the algorithm, how to predict how much various houses cost, right? So if you have a really good algorithm, for example, to predict a house, then you can tell, oh, that house A, I think according to the model, according to the algorithm that I have, it's worth $1 million with 90% like confidence level, um, because you really have a good model, or even like 99% accuracy, right? So if you have that kind of model, that kind of algorithm, that's powerful. Because if you see there is a house that's like selling under 1 million, for example, like only 700 or 800 or 900,000, right? Then you can like confidently, okay, I'll just borrow money from the bank. We'll just buy for 900 because I'm pretty sure 99% like accurate or sure that we can sell it within like 1 week for 1 million. So we can like earn like 100,000, right? About 10%. So so you ask your cousin how is predicted real estate values in the past, and he said it is just intuition, right? Um, but more questioning reveals that he's identified price pattern from houses he has seen in the past. That's when people say about intuition, but actually it's their accumulated kind of experience because they've been in the industry for so long. They recognize all of this pattern that help guide him to decide at what price that house should be. He kind of couldn't explain it why he would have guessed that house is 1 million or 2 million or 10 million or 2.4 or only 100,000. He called it intuition. This is what uh, basically is based on repeated uh, seeing all the patterns in the real world, right? So he uses those patterns to make prediction for new houses he's considering. Machine learning works the same way, right? It's also learning based on the real world data. It's just machine has no emotion. That's the thing. Algorithm doesn't have emotion. It's a math. It's mathematics. So you take out emotion from the equation, right? Sometimes when including me, I used to play stocks quite a bit before, and then I lost kind of a lot of money during the 2008 crisis. I used to buy and sell stock based on kind of emotion. Some of them, not all. So when the stock go low, I was kind of like get afraid, and then I sell it, and then I lost money at that point. of time, right? So, right. So this is one of the fundamental why I think our world is going to be better to be ruled by algorithm, by mathematics, or kind of by computers, because mathematics or computers or machines doesn't have emotion. So they could objectively decide what is kind of the best alternative course of action, right? Based on the pattern, right? On the historical data. And this is also kind of like a very debatable topic right now. Many of the people think, oh, if we replace, for example, judge uh, as just an algorithm, as a machine who decide like this person goes to jail or this person like have like 2 years jail sentence or just like 1 week of community service, that seems like unhuman. But basically, I think the data when you think about it, it's much better because judge is a person just like you and me. We can become emotional and even sometimes we don't feel that we are emotional, or we think we are not biased, but we actually sometimes we are biased. So we are kind of prone to uh, because that's what makes us human. We have emotions, and to if you take away all those emotions, then you can sort of use the algorithm. So anyway, we'll continue. So we'll start with a model called, so the model or the algorithm in this case is called a decision tree. There are more fancier models, in the world of data science or mathematics. There's so many like fancy names for this that give more accurate predictions. But this is kind of the the most intuitive, like easy to understand, right? Decision trees, right? Um, and the basic building block for some of the best model in data science. So for simplicity, we'll start with the simplest possible decision tree. So uh, we'll ask the question, does house have more than 2 bedrooms? And then yes or no. So if it's yes, it has more than 2 bedrooms, then the predicted price is 188,000, right? If it's no, then could be 178,000, right? So and it divided houses into only 2 categories. The predicted price for any house under consideration is the historical average price of houses in the same category. We use data to decide how to break the houses into 2 groups, then again to determine the predicted price in each group. Mm. This type of capturing patterns from data is called um, fitting or training the model. The data used to fit the model is called the training data. So if you want to um, capturing patterns from data, this type is called training the model, right? So how do you get this model? How do you get this um, decision, right? Who create this rule, right? So if the house more than 2 bedrooms and then the price is 188, why not the price, for example, a million? Why not the price becomes like 150? Why not the price become 185? Who created this rule, right? The answer of this. So in order to create this answer, or in order to capture this pattern, so for example, if it's more than 2 bedrooms, yes, and then it's 188, and then no, it's 178, then you kind of like have to train the model. You have to train this decision tree in order to arrive into a specific um, answer, specific algorithm, right? So the data used to fit the model is called the training data. So uh, and you need the data to basically to train this model, and that data is called training data. Okay, so the details of how the model is fit and how to split up the data is complex enough. that we will save it for later. After the model has been fit, you can apply it to new data to predict prices of additional home. Okay, so now you can improve the decision tree. So which of these two is more likely to result from fitting the real estate training data? Okay, so we have two decision tree. It's asking the same question. Basically, house has two bedrooms. Um, the difference is over here is if it's yes is 188, but the other model is if it's yes is 178, right? But if it's not 188, so which one is more likely, do you think? My guess is this one, right? Because the more bedroom normally, I would assume if everything is the same, unless if there's something not kind of by default, but if everything is the same, that I think the more bedroom is going to be more expensive because it takes more kind of labor, it takes more resources to build just another room, right? It's just common sense. So it says here the decision tree on the left probably makes more sense because it captures the reality that houses with more bedrooms tend to sell at higher prices. Okay. The biggest shortcoming of this model is that it doesn't capture most factors affecting home price. So there are a number of factors. In this case, we are just considering the number of bedroom, right? But there are also lot sizes, um, location, or even how old is the house. Um, Probably the older normally is the probably the cheaper it is, but it's not necessarily true. Some houses they become so old they become like a antique kind of. It becomes expensive too, right? So and some houses also has like probably the amenities like if the kitchen is like or the basement is fully furnished or not, right? So there's so many factors. So and we can capture more factors using a tree that has more split. These are called deeper trees. So for example, a decision tree also considers the total size of each house. Lot might look like this. So first asking more than two bedrooms. If it's yes, asking another one. The lot size more than 11,000. If it's yes, then this is the predicted price. No, this is predicted price. And then um, if the lot sizes is just 8,500, right? If it's less than two bedroom, then this is the predicted price. And then if it's no, this is the predicted price. Yeah. So it becomes more complicated, right? So you predicted the price of any house by tracing through the decision tree, always picking the path corresponding to the house characteristic. The predicted price for the house is at the bottom of the tree. The point at the bottom where we make prediction is called a leaf. So this is called a leaf, right? So basically this is kind of like the trunk, right? And then this is kind of like it branches out, right? And then at the end is kind of the leaf, right? Or you can think of it as a fruit, but I would think of it as a leaf because the leaf is just like more common. Not every tree has fruit, right? Um, the split and values at the leaf will be determined by the data. So, so the split, how many times it's split? So this one is split like one time, right? And then split again two times, and then this is split again over here three times, right? Uh, Obviously, the more split it has, the more complicated, right? So and the values also will be determined by the data, right? So it's time for you to check out the data you'll be working with. Okay, so examine your data. Okay, I'm gonna stop here. I'll continue on the next session.